Today in the workshop we'll be doing more work with XOD. We'll learn how to use multiple patches in our programs and how to create our own custom nodes. We'll learn about using XOD libraries, and then we'll start working on our XOD robot. We'll build the robot and learn how to control its LED and its motors. We're making things move with XOD today, so welcome to the workshop. Hey, welcome to the workshop and to the second video in our series on programming with XOD. Now, I need to let you know that like the first video, this video has been sponsored by the folks at XOD. Now, what is XOD? Well, if you didn't see the first video, and I strongly advise that you look at that, XOD is a graphical programming environment that can be used to develop programs for the Arduino without writing any code. XOD is a free open source product that can be run in a web browser or can be downloaded and run on a Mac, Windows, or Linux machine. And with XOD, you can develop applications very quickly without the tediousness of actually having to write any code. Now, XOD is not going to replace your Arduino IDE. I've already been fairly clear about that, but I want to reiterate that. But however, for many applications, XOD is ideal for getting something quickly developed without having to write a great deal of code. Now, in our first video, we looked at the basics of XOD. I showed you how to install the XOD IDE onto your computer, and then we used XOD to create two different projects. The first project was a simple blinking light project, very similar to the blink application that we write with the Arduino IDE. The second one was a temperature and humidity sensor with an LCD display that could be switched between Fahrenheit and Celsius. And while our second project was certainly more complicated than the first one, it still wasn't a very complicated project. Well, I want to start writing more complicated projects with XOD, and in order to do that, we're going to start working on a XOD project that will continue on through a couple of different videos. And this is the project over here. This is my XOD robot, or at least this is the XOD robot as it looks right now, because as we continue, it's going to get additional features on it. Now today, I'm going to show you how we put together the basic robot and how we can control the motor and the big LED that I've got on top of the robot by using XOD. As future videos go on, we'll add more features to our robot, and you will see how a complex XOD project can be built. Now, one comment I had about XOD, and I got a lot of great comments about XOD in the first video, one comment was, though, that doesn't things tend to get a bit busy when you have a complex program? Wouldn't it just be very, very difficult to read with all those boxes and all those lines, etc., etc.? So I'm going to address that today and show you how you can write your programs onto multiple patches. I'm also going to show you how you can use a patch as a node and how you can add extra libraries to your XOD IDE in order to work with components that are not in the IDE to begin with. So there's a lot to cover today, so let's get started by taking a quick look at our XOD robot project. So here's our little XOD robot. As you can see, it's a fairly simple design. It's on a standard robot base that you can buy pretty well anywhere. It's got two wheels and a caster on it. There's also a little power switch on here, and that's to switch the supply voltage to the motor on and off. Now, speaking of supply voltage, I've used 4 AA cells to provide 6 volts over here, and this is going to be for powering the motor, as well as for an additional servo motor that isn't on the robot at the moment. That's for a future iteration of the design. Over here I've got a USB power bank. I've got another one just like it over here to show you. These devices are great. They contain a rechargeable battery. And what you do is you take a micro USB cable and plug it into here from a standard USB charger to charge this device up. And then after that, you can start powering devices off of it by using this jack over here. So I've got a small cable here. I'm going to plug it into there. I'm going to power up this Arduino Mega that I've got on the top of the robot over here. The Mega is going to be used for the robot's intelligence. Now, you could use an Arduino Uno. It'll fit onto the same mounts over here. And for today's video, I'm not using any pins that are Mega specific, so you can use an Uno. But I wanted to use a Mega because we're going to be expanding this robot. We're also going to be making use of the extra I/O pins on the Mega, and perhaps even some of the extra memory that the Mega has. So that's why I started with that. Now in the front, we've got an L298N motor controller. We've seen that before. It's an H-Bridge, and that's just driving the two DC motors. On the top, I've got a power distribution board that I wired up. And this basically is just taking the 6 volts from the battery and the 5 volts from the Arduino. It's sending it down to this board. It's also bringing it out onto pins over here so that I can do future experimenting. And I've also got some connectors I've wired here. I don't know if you can see that. These are for the servo motor I was talking about. I wanted to power the servo motor off of the 6 volt power supply and not off the Arduino's 5 volt supply, because I don't like powering servos from the Arduino power supply. And so that's why I've elected to use 6 volts and not 7.5 like I have in some of my other designs. So as you can see, it's a very basic robot design, and we'll be expanding upon this in this video and in future videos, and we're going to be making this robot run and work with XOD. So here are the components for our XOD robot project. I've laid them out in the workbench because I think it's going to be a bit easier while we're experimenting if they actually aren't on the robot base and running around the room every time we make a coding change. So here's the components as follows. I'm using an Arduino Uno for these experiments because, as I said before, although I'm using an Arduino Mega on the robot, I'm not using any pins or features on the Mega that aren't also present on the Uno. So you can use either one and it'll work just fine. Now here are my 2 motors. I've got little encoder discs on the motor so you can observe their rotation a little easier. This is the L298N H-Bridge motor controller. Here, of course, is the 6 volts I've got in the form of 4 AA cells. Here's my RGB LED. This is a big LED I had left over from the video I did on RGB LEDs. It's a 10mm LED, and it takes more current than many RGB LEDs, and so that's reflected in the value of the dropping resistors that you can also see here on this board here. And so we're going to be using this setup in order to test out our XOD code. So now let's take a look at how it's all wired up. So here's the wiring for our XOD robot. Now we will need either an Arduino Mega or an Arduino Uno. I'm showing an Uno on this diagram, but the wiring is identical for both. You'll also need an L298N motor controller, 2 DC motors, an RGB LED. I'm using a 10mm RGB LED, but you can use a standard 5mm one if you wish. Dropping resistors for the LED. Now I'm using a different value for my red segment as I am for the green and the blue segment. And again, because I've got the 10mm LED, the dropping resistor values I'm using may not be the ones correct for your LED. I'm passing 20 milliamps through each segment of the LED, and so I'm using a 150 ohm dropping resistor for the red and 75 ohm dropping resistors for the blue and the green. You'll also need a power supply for the motor. I'm using a 6 volt supply consisting of 4 AA batteries. Now here's how we'll wire the components. We'll take the ground from the Arduino and connect it to the ground on the L298N motor controller. We'll take the 5 volts in the Arduino and we'll connect it to the 5 volt connection on the L298N. We'll also make sure we remove the jumper on the L298N controller so that we can run from an external 5 volt supply. We'll take the 6 volt power supply, connect its ground to the ground on the L298N, and connect the positive 6 volts to the input for the positive motor supply on the L298N. The Enable A pin on the L298N will connect to pin 3 on the Arduino. Input 1 will connect to pin 2. Input 2 will connect to pin 4. The Enable B line on the L298N will connect to pin 6 on the Arduino. Input 3 will connect to pin 7, and input 4 to pin 8. Now for the LED wiring. We'll connect the red segment of the LED through a 150 ohm dropping resistor to pin 9 of the Arduino. We'll connect the green segment of the LED through a 75 ohm dropping resistor to pin 10 of the Arduino. And the blue section of the LED will go through its 75 ohm dropping resistor and connect to pin 11 of the Arduino. Connect the common lead of the RGB LED to the Arduino ground. And finally, connect the two motors to the L298N motor controller. And this completes the wiring of our robot. So now that you've seen how all the parts for our robot are hooked up, it's time to begin programming with XOD. Now the first element we're going to program for is the RGB LED. Now as you recall, an RGB LED is just a red, green, blue LED in the same package, and we can use it to create a multitude of different colors. If you're unfamiliar with RGB LEDs, I just did a video on RGB LEDs, so you might want to check that out. Now, in order to program the RGB LED with XOD, we're going to need an RGB LED node. And when we look in XOD, we'll find there is no RGB LED node. Well, we could use 3 separate LED nodes, and that would work just fine. But I want to show you a technique in which we can create our own custom nodes with XOD. So let's take a look at that right now. So let's use XOD to control the RGB LED and the 2 motors that we have on the workbench. Now I've opened up my XOD IDE and I've started a new program. So I've got one patch which is called main. And I want to control the RGB LED to start with. Now I can go into my common hardware here and look for an RGB LED, but I'll tell you right now I'm not going to be very successful in finding one. By the way, in order to find a node, a much quicker technique than scrolling through the library is to double-click on an area on your patch. This will open up a Search Nodes box. And from here you can just type in the name of the node you're looking for. Now I'm looking for an RGB LED, so let's type in RGB. And I get a couple of results, and as I highlight them I'll see what the actual node is. None of these seem to be the RGB LED I'm looking for. Let's look for an LED. And again, we get a couple of nodes, including the common hardware one, the LED that we're used to using. Now, if I want to use the LED or anything that I find in a search, I just need to click on it. And then it'll appear right here in my patch. Now, I could use 3 LEDs to control my RGB LED, because after all, an RGB LED is just a red, green, and blue LED in the same package. But I think it would be a lot more convenient if I had just one node that could control the entire RGB LED. So what I can do is I can actually make my own node. So let's get rid of this LED by highlighting it and hitting delete. Then we'll go into File, and we'll make a new patch. You can also do this with Control N. You'll get a dialog box that asks you for the name of the new patch. I'm going to call mine RGB LED. And it's conventional to do this in lowercase, by the way. And I'll hit Confirm. So now we've got another patch called RGB LED. So let's open our search again, and we'll look for an LED. And here's our LED, so let's put one onto here. Now we've highlighted the LED, let's do Control-C to copy, and Control-V to paste. Here's a second LED, let's do another Control-V. And now we've got 3 LEDs, which is what we want. Let's just bring them down over here so we can work on them. Now, let's go into the description for each LED and just change it a bit so we know what they are. This is my red, my green, and my blue. So my red, green, and blue LEDs. Now what I want to do is I want to create a node using this patch, and in order to do this I need to be able to create input and output pins like any node has. And if you go into this library here called XOD patch nodes, you'll see a number of things you can use. A number of inputs and a number of outputs. Now let's take a look at one of our LEDs. I've got one highlighted here. And it's got two inputs, a port and the luminance, the LUM. Now these are both of type number. You need to know this. So we're looking for an input number. So this is an input number. Let's bring one up over here. In fact, let's bring a bunch of them up because we've got 3 LEDs and they've each got 2 inputs. So we need 6 of these. So I'm going to Control C and then Control V a number of times. Okay, so now I've got 6 of these. Let's just move them around so they're a little easier to see. Okay, what I'm going to do now is make a link between these and between the actual pins on my nodes. Okay, now I'm going to go into each of these input numbers and just give it a bit of information, like specifically a name. Now this is going to the port on my red LED, so I'm just going to call this R-port. That's all I really need to do here. And I'll do the same for the rest of these. Okay, so I've given a name to all of these different inputs. And that should about do it for my RGB LED, at least for right now. Now let's go back into my main patch. First of all, I'm going to save my program, which is not a bad thing to do. I'm going to call it, I'm just calling it RGB control. You can call it anything you like. Now if I look under my project, I'll see I have RGB LED, and if I look in here and drag it, I actually have a node called RGB LED. And you'll notice that my node has like an R port, an R lum, a G port, G lum, and a B port and B lum, just as I defined it. You'll notice I have no descriptions for any of these ports. I could actually add them if I wanted to. I'll go back into my RGB LED, and let's go to the first one, for example. I'll give a description to this. Now let's go back into here. And as you, oops, I didn't mean to do that. Let's go back into here, and as you can see, I've now got a description, which I've written myself. So you can create descriptions for everything, including the RGB LED itself. So you can create a node that's just as useful and versatile as a built-in node. So let's see if our node works. So I need to add the port numbers. So the red is going to 9, pin 9 of my Arduino. G is going to pin 10. And B is going to pin 11. Okay, let's give some luminance values to things. Let's give a value of 1 to red. Now remember, these values go between 0 and 1, and because I've got the LED connected to ports that support PWM, I can vary the intensity of the red, green, and the blue. So I'm just going to set red to 1 right now. Save my project. And upload it to my Arduino. Okay. And as you can hopefully see, I've got a light that's lit up. It's a little hard to see the color of this right now. No bending it doesn't do anything. But trust me, that's glowing red right now. Go back into here if we wish. And we'll set the blue on. So now I've set the luminance of the blue to 1. Let's just deploy that. And it is now deployed in blue. So as you can see, I can control the RGB LED with a node that I created myself out of another patch. So now that we've seen how we can control an RGB LED with XOD, it's time to move on to controlling our DC motor using the L298N H-Bridge controller. Now, this is another case in which you're not going to find a node already pre-made for the H-Bridge controller in your XOD IDE. Now, unlike with the RGB LED where we created our own node, we're going to solve this problem by adding a new library to our XOD IDE. And I'm going to show you how to do that, because just like the Arduino IDE, you can add new libraries into your XOD IDE when you're dealing with a component that wasn't part of the original IDE. So let's take a look at how we add a library to XOD and how we use it to control the L298N motor controller. So now that we've seen how to use XOD to control our RGB LED, let's move on and control our two motors. Now, of course, our motors are being controlled with the L298N dual H-Bridge motor controller. So that's the type of a node that we need to add to our patch. So I'm back in the main patch. I want to add a controller for that. So I'm going to double-click and search nodes. L298N, and there's one that is called H-Bridge DC motor controller, and it looks like it might be promising except for one thing. When I'm looking at the pins on it, I've got a speed pin for setting the speed of the motor, and that's fine. A PWM pin to go to the PWM controller line, which is called the enable line on my L298N, that's fine too. And then a pin for direction. But actually on the L298N, I've got two pins for direction, not one. One is the inverse of the other. And so this isn't going to work properly for me. So I've got two choices. I could actually build my own H-Bridge DC motor controller using this one as a prototype and just adding an inverter into it, and that would work fine. But there's another way of doing it, and I want to show you that. Now, most of the hardware that we worked with before has come from the XOD Common Hardware Library that we've seen down here. Now this hardware, of course, is hardware that we created. This is a node we've created to represent an RGB LED. But when you need a node for some hardware and it isn't in your XOD Common Hardware, there's a possibility that someone else has created it and placed it in another library. The XOD IDE, like the Arduino IDE, can have other libraries added to it. So when you need to add a piece of hardware that isn't built into your IDE, you can simply install the library containing that piece of hardware. So let's look for one for our motor controller. And here's one that will actually work perfectly. Now, I looked in the XOD libraries, which is part of the XOD website, and you can go to the XOD website at XOD.io. And then go into the library section, and you'll see a number of different libraries. The one that I found was this one. It's an H-Bridge with two DIR pins on it. Basically, it's the exact same thing we looked at before, except they've got two pins for DIR, and that's going to be perfect. So the way I install this library is I take a look at the actual part number, and the beginning of the part number is always the name of the library. So I'm going to copy that. Go back here, under File, I'm going to add a library. It's going to ask me for the name of the library. So I'm going to look for this. And this is it over here. So now another library is being added to my XOD IDE. If I look in that library, I'll see I have one node, which is the H-Bridge I'm looking for. Now let's bring that out. Now one thing you'll notice about this H-Bridge node is this is just a single H-Bridge, whereas the L298N is actually a dual H-Bridge. So let's make a copy of this node. Control-C and Control-V. And we'll just label them. Motor A and Motor B. Now let's take a look at these pins. The two DIR pins are the Enable 1 and Enable 2 lines. So I've got connected to pins 4 and pin 2. The PWM input is the Enable line, and I've got that connected to pin 3. Remember, this is the one that supports PWM. Let's set up Motor B. Okay. So the key to controlling our motors is on the speed pin. Now if you look over here, it'll tell you it's a number, and it can go from -1 to 1. Now a speed of 1 is full speed ahead, forward. A speed of -1 is full speed in reverse. And a speed of 0 is to stop the motor. And any number in between will give you a gradual speed between 0 and 1 of the motor. So let's just set this to 0.6. And this is motor A. And motor B, let's just set this to -0.6. So each motor should spin at about 60% of its speed, but motor B should spin backwards from motor A. Let's just save our project and deploy it. So my two motors are spinning, and they're spinning in opposite directions because I told motor A to spin forward and motor B to spin backwards. And they're going at about 60% speed right now. And so there you have it. As you can see, it's pretty easy to control our motors using XOD. So now that you've seen how to control both the LED and the motors on the workbench, it's time to move everything over to the actual robot chassis itself. Before we do, though, there's one thing I want to mention. The nodes we've looked at so far are very good at controlling the devices that we're using, but they don't work well in what I would call sequential programming, which is something we're going to need for our robot. What I mean by sequential programming is when the robot gets an instruction, such as move ahead for 2 seconds, and then another instruction, move left, and then another one, move right, turn the light on, turn the light off, that sort of thing. What works very well in XOD for sequential programming are nodes that are set up with an input called a set and an output called a done. Now these work with pulses, and as you recall from our first XOD lessons, pulses are very important in XOD. We used a square wave generator, for example, to flash a light on and off. We used pulse inputs when we developed our digital thermometer and humidity indicator in order to refresh the display. So pulses are a very important concept in XOD. So what we need to do is convert the nodes that we've just built into sequential nodes, nodes that we can turn on, tell them what we want to do and how long we want to do it for, and then when they're finished, they will send a done pulse out to the next node, which in turn follows its particular instructions. So let's go ahead and take the nodes that we've already worked on and convert them into sequential nodes. So I'm going to build a couple of sequential nodes. I'll be able to use these nodes to control the operation of my robot. So I'm going to need nodes for both the RGB LED and for the H-Bridge motor drivers. So let's start by building one for the RGB LED. Now I've got a new project over here, so it's got nothing in the main, and I've got another patch, and that patch is the RGB LED that we built earlier. Now there's one thing I've done to this patch just to enhance it a bit, and I wanted to show you that. Right now, if you take a look in the description of the patch, I've actually got a full-fledged description over here, and I essentially stole that from the description of an LED that I took here, and then just modified it a little bit so that I could say RGB LED. And I did the same thing for all the input pins as well. So for example, for the R port pin, I've got a complete description over here. And if you go down to the LED, I've just taken a description from that and basically said red LED is the only thing I added. And I did that the same for the G port and the B port, for example. I also did that for the other pin, for the R lum pin over here. I took the luminance description and added it to that. And what that's going to do is that when I go to a project, let's say I went into my main and added one of my RGB LEDs into the picture. Now if you look at the help screen, I've got a complete set of help descriptions for every one of the pins and for the RGB LED itself, so it looks like a proper node, exactly like a node that's already built into the common hardware collection over here. So this is a very good technique, and it's a very good thing to do when you're programming. That way, when you build some of these custom nodes, you'll know what all of these pins actually do. So let's delete that right now, because I'm not going to use that here. Instead, what I'm going to do is create a new node, which you can do with Control N, or you can go up to File and do New Patch. And I'm going to call my patch Event RGB LED Display. And the reason I called it that was that this is an event. This is an event I want to happen. And so I'm going to call all of my sequential nodes prefixed with the word event. And so an event and then what it is I want to happen during the event. So in this particular one, I want to display something on the RGB LED. So the first thing I want to add to this patch is an RGB LED. Alright, so I'll take my RGB LED, and we're familiar with it. I'm not going to do anything to the RGB LED itself. Remember, I'm trying to make a node that I can use in a sequence. And so my node's going to need a set input, and it's going to need a done output. And those are both pulse inputs and outputs. So I may as well add those right now. So if you remember, we go to XOD patch cores. I can do an input pulse. I'll place it over here. I'm going to call this set, and I'm going to look for an output pulse. I'll place it somewhere down here, I guess, and label it done. Now what I want to do is I want to be able to go into this and to illuminate my RGB LED to the RGB values of my choosing for a specific amount of time, and I want to be able to choose the time. So what I'm going to do is I'm going to add a delay node in. That's going to cover a lot of the logic for me. So I double click here to search for nodes, and I look for the delay node, and it's a core XOD node. So let's put that here. Let's just move this up a little bit. Now if you look at the delay node, it already has a set input on it, and it has a done pulse output, so it's actually very good for creating these little nodes. And what the delay node will do is it's got this pin called T, and that's the amount of time, specified in seconds, the delay will occur. During the delay, this pin that says ACT will go true. So this will be true during the delay period, and then it'll go false afterwards. And once the delay is finished, it'll send out a done pulse. It is started by sending in a set pulse, and you can reset it in the middle of a delay by giving it a reset pulse, which we're not going to use. So let's connect my set to this set on this delay. I'm also going to get myself another input node. This will be an input number. And I happen to know I'm going to need quite a few of those input numbers. In fact, I believe I need 6 more. So I do a Control C, Control. Okay, I don't know, I may have grabbed a few too many over there, but we can always delete them later. Let's just move them out of the way. Okay, this one I'm going to use, I'm going to connect it to the T, and this is the time input. And so I'm going to call it T. I'm going to go down into my delay, get the description here, copy that, and then go back into here and paste that description in. Okay. Now the next thing I'm going to do is, you see I've got a done output over here. Now you might think I'm going to connect that directly to the done output of the delay, but I'm not going to do that. I'm going to use another node first, and I'll explain why. Let's look for defer. I'm going to take a defer pulse. Now defer is a node that we're going to be making a lot of use of in the next couple of demonstrations. What defer does is it waits until XOD is finished doing all of its processing before it makes the next move. And it can be very useful in creating loops and doing timing things. Like in this case, we're going to send a done pulse out, but it's possible that the other logic we're going to put in here might still be doing something. And so defer will make everything wait until it's truly done before it sends a pulse out. So I'm just going to connect done to here, and I'm going to connect this to the done output. So now here's my done output with a defer on it. Okay, now I'm going to need a couple of other basic nodes over here. But before I do add them, I'm going to add a few more connections. Now the first one I'm going to add is to the R port. I'm going to skip one here, add this to the G port, skip another one, and add that to the B port. And I do have the right number of inputs. Okay, so let's label these nodes. Now this is the R port, so I'm going to call it R. And once again, I'm going to go into the actual device itself and just copy the description here and place it into the description for the R port. I'm going to do the same thing for this, which is G port, and then for the last one, which will be B port. And the description will be basically the same, except it's going to be so I'm not going to connect the luminance pins directly up to these input ports, and the reason for that is that I want to be able to turn the LED off. If I connect them directly and give them values here, then there's going to be nothing to say switch everything off to 0. So in order to do that, I'm going to add another node. You remember our if-else node. Let's add 3 of those actually. We've worked with if-else before. Let's make 2 copies of it. Control-C and then Control-V. Control-V should do the trick. And move one of them about here. The other one will move about here. I guess we'll stretch you back a little more, move you out a bit more. And you can move over here. Okay, now, if you remember, an if-else has a true and a false input out for here. And we set a value on these, a number value. And this is the condition input, and this is the output of the if-else. And so when the condition is true, whatever numeric value is sitting here in the true will be passed out to here. If the condition is false, whatever value sits at false will be passed out to here. So I'm going to connect our outputs down to the looms. I'm going to connect the true values to our inputs, because this is the value I want to pass down. And again, I'm going to label my inputs. This will be RLum. And I'll take the description of RLum. I'll do the same for this. Okay. Now let's just drag a little bit of this stuff down so we can move these down a bit. Okay, very good. Now all that remains to be done is to take these condition inputs and hook them up to the act output of the delay. And so I'm going to do that, all 3 of them. Alright, and I'm going to save my project. So again, what's going to happen is we're going to set a delay over here. The delay is going to be specified by the T. During the delay period, this condition will go true, and while it's true, it'll pass the value here down to the luminance port. And this will cause the LED to glow in whatever color we're specifying on these 3 pins over here. When everything is finished, this act line will go false, and we'll get a 0, which if you look at the if-else over here, 0 is what's sitting on the false side, and 0 will turn the LEDs off. While all of that's taking place, the defer will be patiently waiting, and once it's done, it'll send a done pulse out. So this is how this particular node is going to work. So let's test out the new sequential node that we just made. Let's drag it onto our main patch. And you'll notice it's got all of its descriptions and everything because we wrote that in when we created it. You'll also notice that it has a T, a set, and a done input and output respectively, and that's what makes it different from our RGB display node that we created earlier. Now let's fill in a few of the values that we know over here. So we know our R port, that's 9. We know our G port, which is 10. And the B port we know to be 11. Okay, now we want this light to turn on for a period of time. Now this is specified in seconds. I'm going to say 4 seconds here. And of course right now it's outputting 0, so it'll output nothing. Let's give it a color. Let's just turn on the red one right now. I'll set that to 1. Okay, so now when this node is activated, it should turn the red segment of the RGB display on for 4 seconds and then turn it off. Now, this is not going to be activated just sitting here by itself. It needs a pulse into the set. So a good pulse to give it is a boot pulse. We'll look for boot. And here we have boot. Now what the boot node does is it outputs a pulse when the program starts, and that's pretty well what we need. So let's connect the output of that to our set. And to save our program, Control S. And deploy it to our Arduino, which is the Arduino Mega sitting on top of our robot car. And we'll see what happens. And there we go, the light's on. And then it turns itself off after 4 seconds. So that works very nicely. So let's do something with this. Let's just take this and do a Control-C to copy it. And I'll make a couple of copies of this. Put them on top of each other. Let's go back to our first one and just label it. We had this one going red, so let's call it red display. Now let's go into this one. Since it's an exact copy, it's already got our pin numbers and time delays in it. Let's change the color. Let's set red to 0. And let's set the blue to 1. Let's call this blue display. Oops. And we'll go into the last one. Make that a 1 and call you. Okay, so I've got it set to 4 seconds for each of these, red, green, and blue. So let's take the done output of red, connect it to the set input on blue, and the done output here, and connect it to the set input on green. And we'll save that. And now we'll upload to Arduino. As you can see, we just went through our sequence. So that's great, except of course once we came to the end here, nothing happened. So it'd be nice to go in a loop, but we can't just take the done and connect it over to the set over here. It won't allow us to do that. You can have only one link going to an input. So what we need to do is bring our good friend defer in. Defer pulse. Now what defer pulse is going to do is it's going to wait till everything's finished, and then it's going to go up and set again. Connect to the input and not the output. Now if I take the output here though, of course I've got the same problem. I can't connect it. There's a solution to that. There's another node called any. Basically, any will output a pulse when any of its imports are given a pulse. So let's connect any up like this and connect that to the set. So now what will happen is we'll have a boot pulse. It'll go through any and it'll pass through and it'll set this. We'll go through our red, blue, and green displays. And after that, done goes through defer, waits till everything is stopped, and sends another pulse up to any, which will pass it through to set, and it should go over and over again in a loop. So let's save that. And now let's deploy it. So there's our red, blue, green, and then it goes back to red again because the loop is running. So this works successfully. So now we've successfully built some sequential nodes that we can use in our robotics programming. Let's now go and do the same thing for the motors. So creating sequential nodes for the motors is pretty well the same as creating them for the LED displays. First of all, we're going to go and create a new patch. I'm going to call this one Event Motor Move, because we want to make a sequence of moving the motors. And so here we are in our patch. Now, of course, we're going to need some H-bridges. Remember that the L298N is actually a dual H-bridge, so we need two of these modules. So let's take one and then Control-C and Control-V should give us the second one. Okay, and let's just label them Motor A, Motor B, and you could do left and right if that's your preference. Now, just like we did for our last sequential node, we're going to use a delay node. So we'll add our delay node in over here. Bring the motors down a bit because I have a feeling we'll have some other stuff up here. And let's do an input pulse. Let's call it set. And link it to the set pin. Okay, and we might as well get our defer pulse. And we'll take an output pulse. Call it done. Spell done correctly. And do that. Okay, now if you think about it, our H-bridges have 4 inputs. 3 of them are the inputs to the dir and the not dir, which are the IN1 and IN2 pins on the L298N, and then the PWM, which is the enable pin. And then we've got a speed input, and this is the value from 0 to 1 that we want it to go, or from -1 to 0 if we want it to go backwards. And so 3 of these pins can actually be passed directly outside of our node right now. So let's get an input number. We know we're going to need one for the T here. Call this T, and we'll take the description for T, put it here. Let's take another input number node. We're going to need quite a few of them. We're going to need 8 in total, so I'll need to copy this 7 times. Control-C. That should hopefully be enough of them. Move them around a bit. Okay, several of these we can connect directly. And the other one will make use of the if-else's like we did before. Alright. Control-C, Control-V, because we need 2 of them. So if-else is going to take the speed value that we're going to connect in over here to its true pin. So whenever the condition here is true, it'll pass the speed value down to the motor. If it's false, it'll pass a 0 to the motor, which will effectively turn off the motor. So let's make our last couple of connections here. Okay, and all we want to do is some labeling now. And we look like we have one we're not using here. Let's just remove that. Okay, and let's save our project. And now we can go back into main and make use of our event motor move nodes that we just created. So let's add our new event motor move onto our main so we can watch it work. Let's pull one out over here for a second. Now to save time, I didn't add a number of the descriptions over here, but in the copy that I have for you to download from the DronebotWorkshop.com website, I'll have all the descriptions in there. Again, like our display nodes, this has a set, a done, and a T on it, along with the regular connections, in this case for 2 H-bridges. So let's go and define those H-bridge connections right now. I'll just get mine out over here. So dir A on mine is pin 4. Inverted dir A is pin 2. And the PWM on A is pin 3. I'll go down here. This is pin 8, which is the same as my IN3. This is pin 7. And this is pin 6. Okay, now we'll set a time we want our motors to run. Let's let it run for 2 seconds. And now we have to set the speed values of the motors. Now remember, this goes from -1 to +1, where -1 is full speed reverse and +1 is full speed ahead and 0 is stop, and any number in between is a smaller speed. So let's set this guy up 0.8, that's almost full speed. I'm going to set this guy to the same speed. So I set both motors to the same speed for 2 seconds. So let's just give this a name again. Call this move forward, because that's what it's going to do. So let's make a copy of that. And we'll go into this one. Let's call this one move backwards, or move reverse. We'll go to our speed values, and we'll make them negative numbers. And why not make one more copy? Call this move turn. Or move spin, actually, I like better. I'm going to set this to 0.5. I'll set this one to -0.5. So the motors will move in the opposite direction. So that's a spin. Alright, so let's add this into my little program. Let's break a few of these links here. Move these things down a little bit more. Okay, we'll slip a motor forward in here. Put motor reverse at the very end. And motor spin. Oh, motor spin too. I think I only want it to spin for about a second. So let's change the time on that. And so now let's just link all of these together. Okay, this link is bad here. It should instead go to here. And this done in this set here. And let's save that. I've got my car ready to load this up to. I'm just going to hold the car because after I deploy it to the Arduino, the motors are going to start moving. I don't want it to move all over the desk. Okay, it's red. The motors move forward. Blue. Our motors move opposite directions for a second. And then green. And the motor reverses. Then it goes red. And it'll start to sequence over again. So there we have it. We've sequenced our XOD robot. So after putting together a robot car, of course, I want to give it a little demonstration. So I'm about to put it down on the floor and run it around so you can see it go back and forth. Now, one thing I noticed about my robot car is it has a little bit of a wheel alignment problem, so to speak. I'm not sure if it's that one motor is turning slightly faster than the other motor, or if one motor doesn't have the torque the other one doesn't, or if it's an issue with one of them slipping on the wheels, but it does seem to pull to one side more than the other. So as a disclaimer, I went into the code and kind of adjusted it to straighten the motors out a bit, but it still does pull to one side. Nonetheless, here it is, the XOD robot car demo number 1. Alright, that about wraps it up for today's video. Now, of course, today what we've done is we've built this XOD robot base, and we've learned how to control both the motor and the LED. We've also used a couple of new programming techniques within XOD. Now, in the next video in this series, we're going to add some additional components to the robot base. You might recall that I said I'd wired up for a servo motor. Well, that's one of the components we're going to be adding in order to give our robot a bit more functionality. So please stay tuned for that. Now, the best way to find out about new videos is to subscribe to the YouTube channel. So if you haven't done that already, please do. I'd really appreciate that, and it'll let you know whenever I make new videos. Another great way of staying in touch is to join the DroneBot Workshop newsletter, and you'll find a link to the newsletter in the description below the video. The newsletter is my way of communicating with you and finding out what I'm doing right and what I'm not doing right, finding out what videos you would like me to make for you. So please consider joining the newsletter so that I can get some feedback from you and help make these videos and articles even more useful for you. Now, as always, there is an article on the DroneBotWorkshop.com website that goes along with this video, so please check that out. The link is also in the description below. Until the next time, please take care of yourselves, and I hope to see you again really soon in the workshop. Bye for now.